condition lah. Yeah. Let's say the bearing capacity is very high, so you can design and apply for shallow foundation. Okay. So in shallow foundation also we have a several typical, yeah. But the common one, the economical one is a bed putting lah. And then let's say you have a very close point of your column, okay. You can combine it as a, they call it as a strap footing, okay. Right. Okay. So why it is normally when you have very close columns, okay, normally you can combine it as a big, huge bed footing, but to optimize, you can apply as a strap footing, okay. This is one of the combination of footing. So as you can see, the different, yeah, between the strap footing and combined footing, yeah. So the combined footing, you need a huge size of bed, yeah. And then also we have a strip footing. Okay, let's say you don't have any column, but your structure as a column, you use a retaining shear, what it calls shear wall as your column, so you can apply a strip footing. Yeah. So for your information also, our technology, current technology, we have a lot of IBS system, right? Okay, IBS system is we call it as an integrated building system, which is you can attach without any casting on site. So all the the panel is made from manufacture in the factory, and then they just attach on like Lego on site. So it's very convenient. It's very to control in terms of quality and assurance, and then it's very fast. So one of it is we call shear wall, which is acting as a column. Okay. Okay. Another this one is, let's say you want to prevent or avoid any problems regarding the differential settlement. Okay. You can use and apply rough foundations, but normally differential settlements happen on the very soft ground lah, yeah, such as pit soil, like soft clay and marine clay. Okay, so this typical of foundation you can apply for your design. All right, so this is how we determine the pile cap, okay, and the column lah, yeah. All right, so actually pile cap footing also you can combine with the deep foundation, such as piling. Okay, so you can support your footing with pile. Okay, with conventional piles. Okay, either is a driven or pile lah. So depend on your design. Okay, and then yeah, so this is one of the typical cross section of reinforcement, bed footing, as you can see. So we have a longitudinal bar, okay, transverse bar, right? So in this subject, you will learn how to determine the sizing and the spacing and the thickness and the size of your footing lah, according to your bearing capacity and your punya dead load. Okay. Okay. So when you design foundation footing, normally the load that you consider is only for dead load. Okay, it's different with the apa ni column and beam. For foundation, you only need to consider the dead load. Yeah. All right. So these are some of the consideration you have to take in account. Okay, and then there's some limitation also. Okay. So for example, like the area of best footing on the allowable bearing capacity. Okay. So you have to be careful also with your proposed area footing. Okay. Because you will, let's say it's very huge or very thin. Okay. It will lead for like punching shear failure, something like that. Okay. So you have to check either the punching shear is passed on your pad footing or not. Okay, there is a one-way bearing. Okay, bending moment. Still, you have to check lah. And then the bearing capacity of your column at best. Okay, dual bar requirement. Let's say it's a need or dual bar. Dual bar is like a short reinforcement lah. Yeah. Then we have a development length of bar and differential settlement. Okay, this just now I mentioned about this differential settlement. You can handle it by designing using a rough foundation. Okay, so this is the equation, how you determine the thickness and the size of the thing lah. So it depends on the permanent and variable load. Okay, permanent means is the dead load. Yeah. Okay, and then for the set weight footing, normally you consider 10% from the service load. Okay, so you have to divide by soil bearing capacity, and then you will obtain the size, the area, okay, of your pad footing. Okay, and then in terms of thickness also, okay, so you can determine, okay, by using the ultimate load, and then also the parameter of column. Yeah. And then another thing you have to check in terms of flexural strength. So you have to look at and the based on the combination of your load. Yeah. So normally we have a few combination of load you have to try, especially when you apply a software like Esteem apa pro what the one of it that we have in the lab is apa Prota. So you can select the combination of your service load, the ultimate. So there is some differences lah between the all the combination, especially in terms of the factor of safety lah. Okay, such as for example in this one we have 1.35 and 1.5. Okay, so maybe there is another combination is 1.2 and 1.4, something like that. So you can choose. All right, and then we have to check in terms of the shear. So for example, let's say your size of your area of footing is very huge, so you have to be careful lah. Yeah, because it will lead for punching shear failure. Yeah, so the sizing of your footing and the size of the column should be adequate. Yeah. All right. So in terms of vertical shear, so it's very important, right? You have to check, especially the spacing between the link bar and the longitudinal bar. Okay. Okay, this one is as I mentioned, you have to check the punching shear lah. Yeah. All right. So the equation also you can refer on the Eurocode. Okay, and then we have the clause on 6.4.3 in bracket 3. Okay, Eurocode 2. So you can look at the value or the equation of how to check punching shear. Okay, and then there is a parameter, so you have to obtain, yeah, especially for checking punching shear. For example, like beta and K coefficient. Okay, and U the length of basic control parameter lah. Yeah. All right. So this where we check the punching shear. Yeah. So as you can see, okay, there is some coefficient like C and D. Okay, which is represent the only the distance, yeah, the sizing of the column. Also the cracking. Okay, so I think all the element of structure such as beam, column, so among the most important you have to check is cracking and detailing requirement, right? Okay, so step to reinforcement design. Okay, in terms of durability and bond requirements, so you have to check, especially for the condition of the bar, okay, and then the compressive strength of your concrete. Okay, so normally in foundation, depending on the your soil condition. Let's say your soil condition is have high content of sulfate, so you have to increase your cover concrete. Okay, and then the compressive strength also should be increased from 35 maybe to 40, something like that. Okay, so to prevent any potential failure from the corrosion, something like that, because in area or soil which have sulfate, very high sulfate, apa ni sulfate itu, so it can penetrate in your concrete mass, okay, and then will lead to corrosion failure. So that's why we increase the thickness of the cover. Okay, that's why in any project, site investigation work is very crucial. Okay, especially checking the soil condition. Okay, either is fully acidic or sulfate, something like that, which is can lead a failure in terms of corrosion for our reinforcement. So you have to take into your account to prevent, okay, any potential can lead to corrosion, something like that. Okay. All right. So for the question, I think this one I just skip lah. Maybe you can check, yeah, learn by yourself. Okay. All right. So this among the the minimum percentage reinforcement requirement. Yeah. So for example, let's say your design is 25 25 kilonewton per meter cube, your concrete strength. Okay. The minimum reinforcement should have, okay, is around 0.13%. Okay. This one is the minimum. Okay, so also it's depending from the strength of the steel. So in this table, the strength of steel we assume is around 500 megapascal. Yeah. All right. Also, and then a different strength of steel will have a different sizing of the diameter of the steel bar. Okay. All right. So this among the table you have to refer lah in Eurocode. Okay. I think previously I familiar with the British standard, but this one is already changed to Eurocode. So I think you can take apa ni learn from the example. So how to consider the design life, something like that. Okay, the material and then the classes. Okay, as you can see in the exposure classes. Okay, so we want to prevent corrosion. Okay, corrosion from sulfate attack and acid attack. Okay, especially the area is nearest to the coastal region, so you have to be careful in terms of your uh, sizing of your concrete cover and then the compressive strength of your uh, concrete. Right. So just now I mentioned is about the concrete cover. Okay, let's say your soil condition is extremely have potential on acidic attack, so you have to increase your concrete cover. All right, so this among the table show the exposure condition. As you can see, we have internal mass concrete. Okay, so normally you plus with the 15 and 20 based on the sizing of your reinforcement. Okay, and then let's say your apa ni for foundation, so you can increase to 30 to I think to 30 to 40 something like that. But depending on the how extreme your soil condition, for example from the sulfate attacks and acidic attack. All right, so this one is for effective depth, so means is I think this one is repairing on the depending on the size apa ni depth for the bottom bar and the apa ni top bar. Okay, all right, so this one is for the individual reinforcement. Okay, for example, let's say you have a number of bar is 10, so the sizing, so the sizing, for example, like in diameter 10 mm, so the spacing will be the spacing will be 785. Okay, between the reinforcement bar. All right, so this is one of the example lah. We look at on example. So let's say you are required to design a square pad footing with single column. Okay, and then you have axial service load, which is 600 kilonewton per meter, and then the variable, okay, 400 kilonewton. Then there's some data provided, like characteristic concrete is around 25. Okay, and strength of reinforcement is 500, and bearing capacity is 150. Column dimension 300 by 300. Design life is 50. Exposure class is XC2. Okay, so all right. So you have to list down all the information first, and then try look at the on the apa nih standard the Eurocode. So what is the typical of especially the classes of the exposure? Yeah. So for example, in this example is the classes exposure is XC2. Yeah. Then you can determine the I think the concrete cover something like that. Okay. Concrete cover is refer to nominal cover lah. Yeah. All right. So you have to check the durability and bond by determining of the nominal cover. So, okay, in this example, okay, so you can refer in table 4.2. Okay, so you have uh, uh, the information from the exposure classes, which is XC2. So you can calculate the value is 12, 25, and the allowance is 10 mm lah. So you just add with your 25 and 10, you will obtain is your optimum nominal cover will be 35 lah. The adequate. And then you have to determine the area of your putting. What is the area? So the area is you have to calculate the combination lot of any service lot lah. Okay, with addition of 10% weight from the footing. Okay, so you have to divide with the bearing capacity. So you will obtain the size of your footing. Yeah. So actually this one you can try whatever size you want, but you have to check until it is apa nih the sub the sizing, okay, is passing the bearing capacity punya soil, yeah. Right. So and then you have to calculate the ultimate forces, okay, it's the axial, yeah, load with combination from the service load and the permanent load lah. So you will obtain around 1,410 kilonewton, right? And then for the soil pressure, okay, for the ultimate load, okay, to determine the maximum of bending moment lah, okay. Okay, why we need a bending moment? Because we want to determine the size of the reinforcement. Yeah. So from bending moment, you can determine first the effective depth, and then after that the area requirement of your bar. Okay, and then they will have a maximum and the minimum. Okay, so your amount of bar should in the range of the maximum and the minimum of reinforcement area. So actually in practical in as an engineer, okay, the fastest way you checking the area, the steel, and then the size of the concrete element, okay, through this maximum and reinforcement area. So, okay, for example, let's say I'm as a resident engineer, I don't have time to refer back the books and everything, okay, to bring all the standard on the site. So in the way to make it fast checking and inspection, so I will use this kind of range, minimum and maximum reinforcement area. So either the sizing and then the size of your concrete element, such as footing, column, yeah, or beam, any kind of element. So if it is still in the range, means the design is adequate. But let's say is uh, more than the maximum or less than the minimum, that means the design is something wrong. That's the way how the resident engineer inspect, on site, punya apa ni, on site punya work lah, especially during the concreting and then assembling the reinforcement. Okay, this is the way how we check. Yeah. All right. So you have to check in terms of shear. So and then shear design resistant. Okay. So all the all the equation have in the standard Eurocode. So you just need to know how to apply the equation and then how to use to determine the, for example, like shear, design shear, vertical shear, cracking, and bending moment, something like that. As long as you know the flow, okay, I think in term of apa ni, during final exam should be no problem lah. Yeah. Okay, and then yeah, after that we have to check the punching shear lah. So yeah, and then last is the cracking. Okay, cracking you have to check also. So all these equation will have in the standard. I think in final exam the standard will be given lah. So it should be no problem for you to calculate, as long as you know the flow, should be no problem. Yeah. So yeah, and among the important thing is how to draw the detailing. Yeah. Okay, let's say yeah, in this case we assume is a square size footing, so means we can make it the size of the reinforcement either is transverse or longitudinal should be the same sizing and same spacing. Okay, so should be no problem lah. All right. So any question, guys? Hello? Hello? Mau tanya kamu nih. Masih ada kan nih? Hello, hello.
Ada dokter.
Ya, ya.
Ada dokter.
Apa soalan? Coba
So
ada soalannya?
far good doctor. No question.
No question. Okay. Okay, if there is no question, I think siapa dia punya class rep? Who's your class rep for this course? Who's your class rep?
Zul dokter.
Siapa
Zul.
kamu? Zul kah? Zuladin kah?
No.
Zuladin kan nih? Yang class rep?
No. Bukan.
No. Siapa? Siapa class rep nih?
Shed.
Siapa?
Shed dokter.
Shirley?
Shed.
Shed?
Yeah.
Shed. Ya, tidak apa. I think Dr. Habib already give you assignment nih. So no need for itulah. So all this apa ni example also will be a similar step lah. You have to check in term of the durability bond requirement, okay, nominal cover, bending moment, and shear, apa ni vertical shear, lagi cracking, punching shear. So it will be a same step lah. Okay, so I think by referring the example should be no problem lah. You have to try by yourself. Okay, for calculation, you have to try and do some exercise. I think kalau itu saja through lecture, apa ni to absorb, to apa ni to obtain the information, I think is very limited lah. It's better you do and do some exercises, especially for the tutorial, yeah. Alright. Apa lagi? Habis lah. I think, yeah. So you should itulah do the tutorial, ya, this tutorial, and then you have to submit to Dr. Abib lah, yeah, for checking. But if you have any apa ni question regarding the design, so you just let me know and text me anytime. Okay, so I can check and then apa ni guide you lah. Okay. Kalau tidak soalan ni, I think the class should be until here saja lah. So you have to try, yeah. Otherwise, I think it's very difficult to gain lah. How to apa ni calculate all these things. So you have to try by yourself. Through lecture is very minimum for you to absorb. Yeah, you have to try by yourself, do the calculation, and check through the standard. Okay, I think the example should be sufficient for you to guide you. Yeah. All right. If there is no question, I think our class until here, and then we will proceed on next week. Okay, let's make it same apa ni day, which is Thursday. Okay, we continue on filing. Yeah. Tidak soalan sudah ya. So if there is no question,
Monday class, dokter?
Monday ada kelas kan?
Ada.
Jam berapa kelas kamu Monday nih?
Pukul 10 kan?
Ya?
Jam 10, dokter.
Jam 10.
Jam 10 kah?
Ya, ya.
Saya pun ada kelasnya buat dia jam 10 tuh. 10.12 ya. Saya advance jauh 10.12. Kalau kita buat kelas hari Kamis saja boleh? Hari Kamis saja lah. Kamis Monday tiada lagi lah. Monday tiada. So kita punya kelas hari Kamis lah. Same macam today. Okay. So on Monday should be no class lah. But if you have any question regarding the tutorial and everything, so you can just let me know. So I will check and guide you lah. Okay.
And another thing,
So, yeah.
Supposedly our test 2 is next week, Monday.
Test 2 Monday.
Yeah.
Oh, tapi itu by Dr. Habib kan?
Yes.
Dr. Habib will,
So,
yeah,
oh, okay.
should be
Yes.
no class lah. For the test, Dr. Habib will be handled.
All right.
Okay, only the lecture. I just replace him for the lecture. I think for the assessment, Dr. Habib will handle.
All right.
Okay, so that's all for today. Thank you very much. Okay, I'll see you on next week lah. Okay, thank you guys.
Thank you, Doctor.
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 Okay.
Thank you, Doctor.
Thank you.